streaming. All right. Welcome to Data Science Club number 14. Today we are going to talk about profiling data sets. So there's some really nice tools to just with one command take a Pandas data frame and then get a whole bunch of different graphs and statistics and things. And so we're just going to play around with that and look at that and see what we can learn about our data sets using those tools. So the links that you'll need are below in the description of the stream. Let's see. I saw this trick first on LinkedIn from this guy, Kevin Markham. Maybe at some point we can ask him to join us for an interview or something like that, because he always is posting these really nice Pandas tools. That's kind of his thing that he likes. So let me see if I can make this a little bigger. Yeah, there we go. All right. So we don't have this installed, but this is going to require us installing this Pandas profiling tool. And so if you haven't already, go back to the very first Data Science Club video and install the Notebook of the Week Anaconda environment. And then once you've done that, go to your on-demand portal, the rc.uab.edu. If you have an account there, if you don't and you're outside of UAB, you can certainly do this on your own Anaconda environment on your machine. But we're going to show it here on the UAB Research Computing on-demand instance.
Yeah, and if you don't have an account on demand portal, send us a comment and we would be happy to discuss how you can do it on your own computer.
Yeah, that's a good point. If you don't have an account with us here at UAB where you can use our system, feel free to send us a comment, and yeah, we'd be happy to help you troubleshoot it on your own machine. All right, so first things first, we're going to go into here to clusters. Well, actually, do we want to do that, or it might make more sense to do something else? Probably clusters would be fine.
Yeah.
All right, so we'll go to clusters, Chiha shell access. All right. And then here we need to ask for some interactive resources because we don't want to use up cluster resources that other people might be wanting to use. And so we need to run a command to do that. So we're going to come to another page and just Google UAB Slurm. Slurm is the job scheduler that we use. And here we go.
And you should come to the wiki that we maintain, docs.uab.uab.edu. And that's where you'll find the Slurm page.
Yeah. All right, and let's make this bigger. And so we're going to come to interactive job. And so we don't need GPUs necessarily for this, but we do like showing the GPU request because we'll use those later for the notebooks and things that we use a lot of times. So the GPU partition is the Pascal nodes. So we're just going to copy and paste this in. We really don't need anything. We actually don't need 8 hours, so we'll probably just ask for it for 30 minutes just to make sure that we have plenty of time. So I'm going to go in here and I'm going to edit this. Let's see, so I'm going to change the time from 8 hours to 30 minutes. All right, so just a real quick rundown. So srun is a command for the scheduler that says, hey, I need compute resources. And then the rest of this are the parameters for that. You can see right now we're in login 001, but after we run this, It should, yeah, so now it changed this to C0113. When you do this, you'll probably get a different number, and that's fine. As long as we're not on the login node, then we're doing good. All right, so now we're going to load the Anaconda module. So we're going to module load Anaconda 3. All right, so now we have Anaconda in our environment, so we can activate our notebook of the week environment that we have. So we go source, activate, nvotw, and that should be exactly the same command if you went through the first video that we had. And so now you see these parentheses, so now we're in our notebook of the week thing. So we can install this library pretty readily. So let's go over here, and we'll just copy this because we're using Anaconda. So we'll do conda install. All right, conda install. -C is the channel or where the library is coming from, and then pandas -profiling is the name of the library. So we're going to do that. So it's going to think a little bit, and then it should start installing, but we probably will have to tell it, yes, we really do want to install it. All right, so yeah, so now it's kicking up. And it may take a couple of minutes, but we'll see.
Yeah, and while it's trying to install, why do you think the profiling of a data set is important in data science?
Well, so a lot of the algorithms are kind of agnostic to what the data is. So it is kind of the human's job to know whether or not the data has any useful information in it.
Mm-hmm.
And it's also the human's job to know whether or not the algorithms are finding something that makes sense. So if you don't look at your data outside of just plugging it into a machine learning algorithm or a statistical algorithm and getting answers, then you may not have any real insights or something that can truly be generalizable. So it's just, it should help us get a good feeling for what's going on in the data and what we expect our algorithms to tell us. Because without that, we don't know, we really are just running it through a black box.
Yeah, and just like William and I have mentioned in our earlier videos as well, that when you are starting up a workflow, it's a very good idea to have an idea about what your data set is. And that's the reason, if you guys remember from some of our earlier episodes, we use the describe function to have some idea of what the data set is going to contain. And you need to find out how many not applicable values are there in your data set, how many zero values are there in your data set, because that would affect the ultimate outcome of your machine learning algorithm.
Yeah, so a real life example is if you have two categories you're trying to classify. Let's say houses that are expensive versus houses that are cheap, and your data set, and you haven't looked at your data set, you may run an algorithm and see that you get 90% accuracy, and you may feel really good about that. But then if you look at your data and see how cheap or expensive is defined and how many things are in each category, if there's 100 houses in the category of expensive and only 10 houses in the category of cheap, then the algorithm can just assume that the answer is always that houses are expensive, and you'll get 90% accuracy.
Yeah.
So that's why it's important to get a feeling here of what's really going on in your data set. All right, so we've installed that. That really didn't take much time, so we'll have to see whether or not it works later. But so we can exit out of this terminal. We don't need to do anything else here. We'll open up Jupyter Notebooks later when we want to use it. All right, so yes, we're going to leave. All right, so now we need a data set. So if you go to Kaggle.com, there's a lot of data sets there that you can look at. Let's just look at so there's a ton of things here that you can download. All of these are publicly available. If you're interested in playing around with any of this stuff and sharpening your skills, you're welcome to do that. If you're having trouble with any of these, let us know. But we found this one in particular. We were just in Chicago for the Research Computing Conference there, PERC, and so this one was kind of interesting to us. Chicago red light and speed camera data, and so this is in the form of CSV files. There you go. So this is in the form of CSV files, and so when you click download, it's going to download it to your local machine. But we want to play with it on Chiha, where our GPUs and our Jupyter notebooks are generally living for our workflows.
And where we set up our Conda environment just now.
Yeah, and where we set up our Anaconda environment. So we're going to go back to that rc.uab.edu and files, and we'll go to our data user directory. And I think we already have a folder here from previous times, rc-dsc. And so we'll create a folder in here. Let's see, new directory. And we'll call this pandas underscore profiling. Okay. And we'll just drop that in there. All right. So, all right, we can leave that there. And now we can come to our dashboard again. And so I don't know if you saw what I did. I kind of skimmed over it. But with this file explorer, you can just drag and drop your files from your computer onto the cluster hard drives, and it will do the transfer for you that way. For the next step, if you're doing this on your local machine, just make sure that you know where you're putting that data so that you can appropriately explore it when we get to that step. All right. So now we need to go back to the dashboard, and we're going to open up a Jupyter notebook. And we can set our notebook directory to that notebook directory equals data user, your Blazor ID, and then rc-dsc. And we only need 1 hour here. And we'll go on the Pascal nodes, because maybe after we do some profiling, maybe we'll want to run an algorithm. Who knows? We'll see. All right, so I'm going to launch that. And then let's refresh. I've got to be patient. Let's see. I don't need this one actively running, so I'll delete this job. Yeah, so sometimes if you're trying to get your jobs to start, if you have old jobs that are still running, you can delete those, and it'll free up some resources so your new job can start. All right. So connect. All right. So now we're going to come in here to Pandas profiling, and you can see we don't have any notebooks in here right now. So we're going to create a new one, and we're going to specify that we're going to use that notebook of the week environment. All right, and so now we are we're in here. We're using it. If you noticed, our data set is still in a zipped folder.
Yeah.
So we need to run a system command to actually unpack that folder so it's decompressed so that we can actually see our data. So to run system commands in a Jupyter notebook, you can just put exclamation mark, and then you can run it. Well, that's odd. Apparently, there's an issue for this particular one.
But
I'm
it
not
works
sure.
in the end. So if you
Yeah.
see the last line, we do have what it wanted.
Yeah, so ignore all this business. This seems to be errors. I haven't seen this before, but if you see it, don't freak out. At the bottom is what we wanted. It actually did list the directories here. So we want to just run the unzip command. Unzip. And there we go. Tab complete generally works in the Jupyter Notebooks. So once you put the single quotes in there and you start typing, it's going to look for a file in there that starts with those letters. So you can tab and then it'll finish it out. All right, so now if we run that, again, we got those errors, but now it's actually, it actually unzipped that archive so we can see what's inside there. And so now if we do that, we go up and rerun that ls command, then now we have all of those spreadsheets in here directly. All right, so now let's look back at our little mini tutorial here. All right, so we gotta import Pandas profiling.
And yeah.
And let's see, where am I? Here we go. All right, so we're gonna import Pandas profiling. We probably also need to import Pandas because we're gonna need to read in the data set. So we're going to import Pandas as PD just to give it a little shorthand. And so we'll leave that in its own cell there. Make sure those two load up correctly. And then here, while that's loading up, we'll read in our data set. So we'll, let's see, do you want to look at speed camera or red light camera violations?
Red light camera violations.
Okay. All right, so we're gonna do data frame equals pd dot read underscore CSV, right?
Yeah.
And then we specify the name of the file we want to do. Again, tab complete works, so we just start, I put my single quotes up, and then I start typing red, and then I tab, and it'll give me a list of what's available. So we can look at locations or violations. Let's look at violations. All right. And there's an error. All right, so what's the error here? Initializing from file failed. That's weird. All right, so now we get to do some live troubleshooting here. All right, so Pandas initialize from file failed. All right. Turned out the CSV I had no permissions at all. The error message from Pandas did not point that out. Check it that your file has read permissions.
Huh.
Oh.
Interesting.
Interesting.
So they could do
Alright.
LL rather than LS.
Alright, so you're saying if I come up here and change this to
Yeah.
LL, then that'll tell us the file permissions.
Oh, it doesn't. No. So I think it might be a alias in my account. Just do an ls-l.
Okay. ls-l.
Yeah, it doesn't have any permissions.
All right. Well, we're getting into some Linuxy stuff here. So we're going to need to change the permissions. So basically, what's happening here is you can see right here. So these are the permissions. So I have read-write permissions for this zip folder, but for some reason, because of the way that these files were created, I guess, the These have no permissions at all associated with them. It doesn't mean that I'm not allowed to delete them or do things with them, but it does mean that the operating system doesn't know what to allow me to do because they don't have anything specified.
Yeah. And like when we were debugging, it said that it doesn't know that it has the read permission, and that's why it's giving out this error. And that's what we are going to change. We are just going to add a read permission or read or write permission.
Yeah. So I believe the command to do that is change mod, right?
Yeah, chmod.
And
you can do
I just do star, right? Because I want to do everything in there, or you want to do that specific file?
No, you can do all of them, but you need to. Actually, let's just try this. Because it doesn't have any permissions. If you want to specify what permissions you want to give, you can do chmod user, so u plus rw.
Okay. U. Here, I'll let you type.
Yeah. U plus rw. So basically, if you see the permissions, there are three. That is one chunk that is for the user, that is for you. The next one is for group, and it again also has three values: read, write, execute, and one is for others or rest of the world. So if you set permissions over here, like if you set read, write, execute permissions, and if there is no limit anywhere up in your tree chain, then anybody can read this file, unless until if you have limitations somewhere up, then nobody can come down here, but if they are able to, then they can see this. So what we are just asking it to do is just add read write over here.
Okay.
And do it for all the files. So
do I need to specify my username in there, or it's just going to assume that I want it for myself?
Yeah. So when you specify you, it means whoever is running, whoever is the user over there at the time. So now you see it's just changed read write over here. If we wanted for other people as well, we could have specified group. So if you wanted everyone in your group to be able to read it, then you specify group, and others is O.
Okay.
So now we should have permission.
Fine. All right. Perfect. Well, and we're just interested in ourselves having access, so we don't need to do the group or others. All right. So now we can read that CSV file. All right. So if you remember from previous times, if you do like a data frame.describe, then that gives us some information, right? What values are even there? So, and what values are here? So there's camera ID, violations, coordinates, latitude, longitude, zip codes, community areas, census tracts, wards. Okay, so most of this seems like almost categorical data. So it'll be interesting
to see how
to see what can be extracted from there, but we'll see. All right, and then let's look at what the instructions are. All right, so df.profile_report. All right.
That's good.
df.profile. Yeah, it doesn't look quite right. It's not coming up as
one of the
things I can do. Let's look at his little video here. Profiling a data frame. Oh, here we go. That's what we got to do. Okay, it is profiling.profile report. Okay, so there was a typo in what he had written. All right. So go Pandas profiling.profile report. And we'll put our data frame in there. Here's a moment of truth. Let's see what happens. Oh, okay, excellent. So that didn't take long.
Yeah.
All right. So this is kind of nice. All right. So it basically breaks down all of that, like it looks like it's breaking down all of the different things that we would normally do to a data frame,
Yeah.
but putting it in one kind of interactive HTML format. So you can see it highlights the text really nicely.
Oh, that's a very cool feature. Total number of missing values.
Yeah, let's see if I can make this even bigger so we can see it better. All right, so yeah, so the number of variables, the number of observations, the total percentage missing, the total size of the data set in memory. So this will help you as you're like planning what resources to ask for if you're on the cluster, or to see if this is crashing on your local machine, if it's a memory issue.
Yeah.
Variable types. Okay, so it shows us some are numeric, some are categorical. Nice. Address. So this thing here where it says something has high cardinality. So high cardinality basically means this might be something that's almost just like a unique identifier.
Yeah. That just means that this might not be. So if you are running some machine learning algorithms where it has to learn some sort of behavior, this might not be one of the things that it should learn on.
Yeah.
Because all of the addresses are unique, like it mentions that they have 316 distinct values.
Yep. And so if we look at all of these ones with warnings, it's saying that they're high cardinality. So they're categorical variables. If we look at the address up here, I don't know if it shows us. Oh, let's look at the head instead of describe. Yeah. So intersection and address. So these are categorical variables, but they are, because they have so many unique values, we might as well be uniquely identifying each point. So if we ran a like XGBoost or something like that on here, it would just use these categorical variables to say, oh, well, I remember this house or this intersection had this violation, this intersection had that violation, such things. So those may not be good variables to train with, is what this high cardinality basically means. All right, let's look. So census tracts has 5% missing values, community areas the same. Let's see, intersection. So this is really interesting.
Yeah, latitude is highly
correlated. So latitude is highly correlated. So we would expect that the coordinate system and the geographical coordinate system would be highly correlated. But this is really nice because, so if you have two variables like that are highly correlated, would you just drop one of those, or what what would you do in that instance?
I mean, at least in the initial run, I would like to keep them, especially knowing that it's latitude and longitude, and depending upon what kind of algorithm that I'm trying to run.
Yeah.
In my initial run, I would keep both of them, but there is a good point to be made that if you know one of them and you already, that means that you know the second value as well, then there is a chance that you can drop one of them.
Yeah, I mean, especially with this high correlation value here.
Yeah.
And given our human knowledge that latitude and longitude are geographical coordinates versus the XY coordinates. So, like Ravi said, maybe in the initial run, you keep latitude and Y coordinate and longitude and X coordinate when you run something. But in order to save everybody time and space and things, you might drop out one of these, because if you have one, you have the other, essentially. And then let's see, violation date. So again, this has high cardinality, and then all these have some missing values. Now this is something to watch out for with addresses specifically. So zip codes is a numerical value.
Yeah.
But zip codes are actually a categorical value because they are specifying a location. So that's that one.
And we just have 11 duplicate rows. So that's not bad.
Yeah, let's look at a different data set real quick.
Did we have anything else apart from that?
I think that was, is that everything? Oh yeah, we did. Never mind. All right, so I gotta go back down in resolution here a little bit. All right. So now it's the breakout of variables. Oh wow, this is huge. I thought that was it. But you can toggle details on here and see things underneath it.
So it also gives on which road you have the most violations.
Yeah. It shows the roads that you have the most violations. That's true. The camera ID, so the cameras that see the most violations. Good to know. And then if you look in here, there's descriptive statistics. So not just what's in the describe of standard deviation, mean, max, and min, and the percentiles, but you also have skewness and kurtosis, which are histogram measurements, which can be really useful. And you can actually look at a histogram here. So that's kind of nice. Census tract, community areas. All right, so this is, all right, so it actually already kicked out these latitude and longitude. It didn't give us descriptive stuff because it was too highly correlated.
Yeah, I mean, one good thing is like if with every column that you get, you have some sort of relevance and data, some sort of stats given over here for each particular column.
Yeah, so X coordinate, it's interesting. I mean, that looks like a fairly normal distribution, which makes sense because once you start to get to the extremes of the coordinate, then you're starting to get to the extremes of Chicago.
Yeah.
My guess, and so that's why it kind of peters off there. Zip codes, and this is what we're talking about. It's really more categorical, so it doesn't make sense to use it as a numeric thing. Correlations, my guess is if we had more numeric variables, we would see something here, but
Sample.
we don't.
So this is the head function that you had.
Yeah, so this looks like that's just a head function. Yeah.
Not bad.
So
that's a lot of data that they have put in.
Yeah, that's a lot of really helpful stuff to have from a single command. So yeah, I'm going to use that more frequently because that's nice. It's like the head or describe on steroids.
Yeah. What were the other ones?
I think there was like a speed camera violations.
That's violations.
Or do you want to look at locations? Or do you want to look at the other red light camera locations?
Yeah, red light camera location.
Alright, so that's the locations, and then we're going to do that. Oh, interesting. So this actually tells us how people approached the light. Okay, hang on a second. Let's go back up to the top here. All right, so this is the camera locations. So there's only a couple of warnings here, which is nice, I suppose.
Yeah.
Mostly for missing values.
Yeah, and most of the warnings are what the program thinks would be warnings, so you might have a different opinion based on what you are trying to do with the data. So just keep that in mind, that you don't have to actually reject everything that comes up in the warning.
Yeah. So take everything with a grain of salt here. I mean, this is kind of interesting. Most of the initial approach issues are for northbound to southbound red light violations, which, given Chicago's orientation and how it is essentially a north-south city right there by the lake, it kind of makes sense that most of the violations would be north-south. That's kind of interesting. Historical. All right. So intersection is again just a categorical variable. Latitude, longitude. So this is where it may make sense, like if you were marrying this table to that other table to get some other insights,
Yeah.
it would make sense to keep the latitude and longitude
Yeah.
because you have them in both
Yeah.
rather than keeping the X and Y.
Second approach.
Yeah, we'd have to read up a little bit more about what first versus second approach is. Okay, there's a sample. So, all right, well, that's really cool. I'll have to find a data set that shows up something under correlations. But my guess is if you had data that had more numerical stuff going on, that you would get something there. So play around with this, try it on a different data set that we didn't try it on, and let us know what you guys thought. Feel free to come into office hours if you're having any struggles with any of this. We'd be happy to talk to you about it. And yeah, let us know what other kinds of things you might like to see for future Data Science Club videos. And if you haven't already, like and subscribe. And if you're at UAB, sign up for the credited course this fall so that if you're doing these videos, you can get a credit hour for it. Anything else?
That would be all. Yeah, just let us know if you come across anything interesting in the data science world.
Yeah. And just for let's see, I gotta find it here. I think I posted it today. Yeah, I found an Inspirational AI. So this is your artificially intelligent inspiration for the day. Whenever you need to destroy your cache, you will fail unless you learn how to think positive. So yeah, this is from a website called Inspirobot. So they're using machine learning to generate inspirational memes.
Oh, nice.
So yeah, but yeah, if you guys come across anything you think is interesting, feel free to share, and we'd be happy to, do whatever we can. So, all right, well, thank you guys.